So hello guys. Well, what I want to talk to you about today on my really messy bench, I have a lot of work to do, are capacitors. Now, if you clicked on this video, you are probably wondering what this is all about. Now, there are a lot of great videos out there, and I'm gonna show you one, but none address the sonic character of each capacitor. So I recently recapped my Harman Kardon, yeah, and after the recap, it sounded terrible. Well, basically, I used just caps that I have lying around. Didn't pay much attention to it because I figured that replacing 40-year-old capacitors is gonna make it sound better. Well, this was not the case, and actually, the downfall of my recap job was this little Nichicon capacitor. My camera won't focus, but anyway, trust me, this is shit. And so I put back the old capacitors and tried to figure out a way to uh, get a sonic character of capacitors so I don't make this mistake again. And in my research, I found out that it's actually very easy. Now, let's get into it. So the next step is gonna be me holding the camera, so prepare for some shaky cam. Be right back. And we are back. So, what you basically need to do is just take a capacitor, yeah, like in my case, hook it up to that's audio analyzer, and you are off to the races. So you start the software. Software looks something like this, yeah, and you click on capacitor test. Now this tests a lot of things, inductance, resistance, and other things, but we are mostly interested in capacitance. Now, as you can see, it tests the capacitor at 3 different frequencies. Now, this is very important because it tests the capacitor in the audible range. So, we hit test. It's gonna do some things and then numbers will appear. Now, this is a 100 UF capacitor. As you can see, the measured value is a bit lower. Usually it's lower in new capacitors, but that's okay. And then we have these values. Now these values I detailed in a forum post. I might paste the address, the link to the forum, but so basically this is the data we need to determine the sound characteristics. Now, after we have all this data, we enter it in a Excel sheet, yeah, and we enter the values, make this little Excel sheet, and we enter the values for all the caps. And I can, as you can see, I have them numbered, yeah. First cap is the old Elna, a Panasonic, a different Panasonic, I don't know what brand, a Nichicon, and this Würth electronics. Now, after you compiled your little Excel sheet, yeah, you need a way to interpret the data. Now, I actually wrote the software for it in Python. It's not bad, but actually AI is better. Now, of course, I have everything set up beforehand, so you don't have to watch me enter numbers uh, in an Excel sheet. But to interpret the data, you will need an AI software. Now, I haven't actually read through this. I don't really know what it did. As you can see, I uploaded the file and it gave me a totally different answer, so I had to tell it to analyze the list that I gave it. Now, you have to teach the AI how to respond to you, how to give you the data, because it can give you I don't know, tons of data on just one capacitor. Yeah, so I actually thought teached it to give me the data that I need, so we don't go off the record. Now, as you can see, another important fact, I just have it labeled Cap1. So I did not enter a manufacturer or a model or anything like this, because AI tends to go the easy way and interpret data from different sources, not from its own memory. Yeah, so if I tell it's a Nichicon, it's gonna say, oh my god, that's the greatest capacitor. But actually that is not true, and you will see this in a few moments. So, without further ado, let's see what it says about these capacitors. Now, if you know anything about recapping, about audio, about capacitors in an audio circuit, you might have heard these capacitors or tested these capacitors, and you will most definitely know how this old Elna sounds. Yes, and you will probably know how this Nichicon sounds. But let's see what the test reveals. So Cap1 is the old Elna. Yeah, it's 100 UF at the 10 volts. So after it analyzes the data, yeah, it gives you this soft, slow presentation. Yeah, bass present but poorly articulated. Mids are veiled, gray. Reduced micro detail. Soundstage exists but very foggy. Yeah, singer position audible but hard to lock. And this is very good. This is what we hear from most vintage amplifiers. Yeah, it's a good sounding amp, but it has no detail. It lacks soundstage and so on. So it's a bit grainy, a bit veiled. That's not necessarily a bad. That's not necessarily a bad thing. I mean, I know people that can only listen to that type of sound. So let's go on to cap number 2. Now, actually, this is a Panasonic. Yeah, this is actually a good audio capacitor, but not the best. For example, I don't like it. But let's see what it says. Warmer and smoother than Cap1. Slightly better clarity. Still compressed dynamics. Yeah, bass lacks punch. Soundstage wide, but imaging focuses remains. Yeah, exactly what I hear when I recap an amplifier with this capacitor. Now let's see Cap 3. Well, Cap 3, I think it's a lower grade Panasonic, maybe for PSU, for exactly for PSU only. So dull, uninvolving, attack blurred, bass sounds thick, mid-range lacks texture, soundstage collapsed. So yeah, that is a rather bad capacitor. Now let's see the Nichicon. Yeah, this is the Nichicon. This is actually not a very good Nichicon. So this is actually an FW series, yeah. But it's a Nichicon. I don't like them. I really don't like. I don't like Nichicons. I don't even like these Vimas. I actually hate Vima capacitors. To me, they don't sound real. They don't sound good at all. Well, let's see what it says about the Nichicon. So, pleasant warm tonality, good for taming harsh systems, still loose of fine detail, soundstage depth reduced but coherent, instruments blend more naturally but less separation. Vintage voicing. Yes, so this is exactly what a Nichicon sounds like. I get it. It's okay. Now, onward to cap number 5. Now, cap number 5, I actually really like. These are Würth electronics. Yeah, I have them in a lot of values. Now, you need to pay attention. There are different brands, different models. This is a W cap. This is I don't know. Well, they should brand them better, actually. Well, anyway, but it's a good capacitor. It's a very good capacitor, especially in the audio signal. I tend to like it. Not very forward, good body to the sound, bit rolled off highs, but I like rolled off highs, so no problem there. Bass is very good. It has very good bass, very good tonality. Well, this is my opinion for my use cases. But let's see what the IE says. So, cap number 5. Clear, open, fast. Excellent transient definition. Bass is tight and articulated. Mid-range cleared and textured. Soundstage precise and stable. Single position clearly defined. I'm sorry, I'm reading it through the camera screen, so it's not that I can't read. I'm trying to read it, but you can clearly see what it says. No fog, no smear. Use in signal path, output coupling. Yeah, so it's a good capacitor. And the test can go on. Now, I need to do this because I have a lot of capacitors. Usually I go on sometimes I go on a capacitor buying spree and I buy a shitload of capacitors for absolutely no reason, and I end up putting Nichicon golds in power supplies, which is actually not recommended, but if I don't have anything laying around, like, I don't care about it. But for example, this is just one box of capacitors, yeah. So I have boxes of capacitors. Usually when I find a good deal on capacitors, I buy them. But for example, these are actually all new capacitors, but it's a mishmash of brands. Yeah, we have something or other. Yeah, we have Rubicons, we have Rubicon Blackgates. I saw somewhere, I saw some Rubicon Blackgates, and those are actually really good capacitors. Well, anyway, need to be able to test it somehow, not end up recapping an amplifier and then going bananas because you spent a lot of money on the caps, on the recapping operation, and it sounds like shit. So we don't want that. This is why let's say it's not accurate. Let's just say it is not accurate. This test is completely inaccurate, but it gives you a reference. So if you have a reference, you will know, for example, not to put in this stupid Saxon capacitor because it's shit. Yeah, and you can maybe go with a, even if you don't put in a Würth, yeah, you get this in your hands, you can still use this. It's better than the Saxon capacitor. So basically this is what I wanted to talk to you about. So you can, if you have a DATs, if you have capacitors, if you like electronics, like fiddling with electronics, you can go ahead, do these tests, get your own information. So what I recently did is I got myself paid AI. Yeah, it goes more into depth and it's more precise. So yeah, I do recommend the Go package for ChatGPT. It helps, it really helps a lot. So for interpreting larger amounts of data, I would have to say that ChatGPT and DeepSeek is very good. So this is all that I have to say to you today. So